Welcome to the session on central difference interpolation formulae. In the previous sessions, we discussed the Newton's forward interpolation formula and the Newton's backward interpolation formula. The Newton's forward interpolation formula contains the initial value of y and the leading forward differences, namely y naught, delta y naught, delta square y naught, etc. It assumes that y naught is the leading value of y in the difference table. Similarly, the Newton's backward formula contains the n value of y and the leading backward differences, namely yn, del yn, del square yn, etc. We may assume that y naught occurs at the center or near the center of the given table values, in which case the values of y preceding y naught will be y minus 1, y minus 2, y minus 3, etc. and the values of y following y naught will be y1, y2, y3, etc. There are 5 central difference interpolation formulae which are derived on the assumption that y naught occurs at the center or near the center of the table values, and that the forward differences at y naught, y minus 1, y minus 2, etc. are available. The first formula is Gauss forward interpolation formula. Second one is Gauss backward interpolation formula. Third one is Stirling's interpolation formula. Fourth one is Bessel's formula. And the fifth one is Laplace-Everett formula. These are the 5 interpolation formulae. In this session, we shall discuss the first one, that is the Gauss forward interpolation formula. Suppose that y naught, y1, y2, etc. and y minus 1 towards the left, y minus 2, etc. are the values of a function y equal to f of x corresponding to the equidistant values of x, namely x naught, x1, x2, etc. towards the right, and x minus 1, x minus 2, etc. towards the left, with interval of spacing h. Here h is the interval of spacing. Then the Gauss forward interpolation formula is y equal to y naught plus uc1 into delta y naught plus uc2 into delta square y minus 1 plus u plus 1 c3 into delta cube y minus 1 plus u plus 1 c4 into delta raised to 4 y minus 2 plus u plus 2 c5 u plus 2 c5 into delta raised to 5 y minus 2 plus u plus 2 C6 into delta raised to 6 y minus 3 plus etc. Here u is equal to x minus x naught divided by h, where x naught is the middle value of x, h is the interval of spacing. This is the Gauss forward interpolation formula. We can derive this formula from the Newton's interpolation formula. We have the Newton's forward interpolation formula. Y is equal to y naught plus u c1 into delta y naught plus u c2 into delta square y naught plus u c3 into delta cube y naught plus etc., where UCR is equal to u into u minus 1 into u minus 2 into etc., u minus r minus 1 divided by r factorial, and u is equal to x minus x naught divided by h. This is the Newton's forward interpolation formula. We know that the forward difference operator delta is delta f of x is equal to f of x plus h minus f of x, and the shift operator is defined as E of f of x is equal to f of x plus h. In the finite differences, we already discussed these two definitions, and we derived a relation between delta and E as delta is equal to E minus 1. From here we can write f of x plus h as E. Therefore, delta can be expressed in terms of this shift operator as E minus 1 means the identity operator. Now, we have delta square y naught can be written as delta square of E y minus 1, because y minus 1 is the previous value of y naught. This is equal to delta square of, from here we can write E as delta plus 1, 1 means the identity operator, delta square of delta plus the identity operator into y minus 1. That is equal to delta square into delta means delta cube y minus 1 plus delta square y minus 1. That is delta square y naught can be written as delta square y minus 1 plus delta cube y minus 1. That is this difference can be expressed in terms of y minus 1. Similarly, delta cube y naught can be expressed as delta cube of y naught means E of y minus 1. In terms of the shift operator, we can write y naught as E of y minus 1, which is equal to delta cube into E means 1 plus delta into y minus 1. That is equal to delta cube y minus 1 plus delta raised to 4 y minus 1. Similarly, delta raised to 4 y naught can be written as delta raised to 4 y minus 1 plus delta raised to 5 y minus 1. And we can express all the differences like this. Using these values in this Newton's forward difference formula, we can write y as y is equal to y naught plus UC1 delta y naught plus UC2 into delta square y naught, that is delta square y naught is delta cube y minus 1 plus delta square y minus 1 plus UC3 into here delta cube y naught, which is delta cube y minus 1 plus delta raised to 4 y minus 1 plus UC4 into next term is delta raised to 4 y naught. We can write delta raised to 4 y naught as delta raised to 4 y minus 1 plus delta raised to 5 y minus 1 plus etc., which is equal to, this can be written as y naught plus, that is y is equal to y naught plus UC1 into delta y naught plus UC2 into here delta cube y minus 1 plus delta square y minus 1 or delta square y minus 1 plus delta cube y minus 1, that is UC2 into delta square y minus 1 plus UC2 into here delta cube y minus 1 plus UC3 into delta cube y minus 1 plus UC3 into delta raised to 4 y minus 1 plus UC4 into delta raised to 4 y minus 1 plus UC4 into delta raised to 5 y minus 1 plus etc., which is equal to y naught plus UC1 into delta y naught. The term containing delta y naught is only one, and here delta square y minus 1, the term containing delta square y minus 1 is only one term. Therefore, we write UC2 into delta square y minus 1 plus here the term containing delta cube y minus 1 is 2. Combining these two, we can write UC2 plus UC3 into delta cube y minus 1 plus here the term containing delta raised to 4 y minus 1 is 2. Therefore, we can combine these two terms. We write UC3 plus UC4 into delta raised to 4 y minus 1 plus etc., which is equal to y naught plus UC1 into delta y naught plus UC2 into delta square y minus 1 plus we can write UC2 plus UC3 as U plus 1 C3 into delta cube y minus 1, because UC2 means UC2 plus UC3 means UC2 is U into U minus 1 divided by 1 into 2 plus UC3 is U into U minus 1 into U minus 2 divided by 1 into 2 into 3. This is equal to, we can write U into U minus 1 divided by 1 into 2, which is common. This into here 1 plus this is U minus 2 divided by 3. That is U into U minus 1 divided by 1 into 2 into, here we can write 3 plus U minus 2 divided by 3, that is U minus 1 divided by 1 into 2 into, this is 3 minus 2 plus U, that is U plus 1 divided by 3, that is U plus 1 into U into U minus 1 divided by 1 into 2 into 3, that is U plus 1 C3. Therefore, we write UC2 plus UC3 as U plus 1 C3 into delta cube y minus 1. Similarly, UC3 plus UC4 can be written as U plus 1 C4, U plus 1 C4 into delta raised to 4 y minus 1 plus the next term will become U plus 1 C5 into delta raised to 5 y minus 1 plus etc. That is y naught plus UC1 into delta y naught plus UC2 into delta square y minus 1 plus U plus 1 C3 into delta cube y minus 1 plus U plus 1 C4 into, here we write delta raised to 4 y minus 1 as delta raised to 4 y minus 2 plus delta raised to 5 y minus 2. That is this difference can be expressed in terms of this y minus 2 plus U plus 1 C5 into delta raised to 5 y minus 1 can be written as delta raised to 5 into y minus 2 plus delta raised to 6 into y minus 2 plus etc. that is equal to y naught plus UC1 into delta y naught plus UC2 into delta square y minus 1 plus U plus 1 C3 into delta cube y minus 1 plus U plus 1 C4 into delta raised to 4 y minus 2 plus U plus 1 C4 plus U plus 1 C5. Here the terms containing delta raised to 5 minus 2 is 2. We can combine these two, that is U plus 1 C4 into delta raised to 5 y minus 2 and U plus 1 C5 delta raised to 5 y minus 2, that is U plus 1 C4 plus U plus 1 C5 into delta raised to 5 y minus 2 plus etc., which is equal to y naught plus UC1 into delta y naught plus UC2 into delta square y minus 1 plus U plus 1 C3 into delta cube y minus 1 plus U plus 1 C4 into delta raised to 4 y minus 2 plus here we can write U plus 1 C4 plus U plus 1 C5 as U plus 2 C5, U plus 2 C5 into delta raised to 5 y minus 2 plus etc. Proceeding like this and grouping the terms, we have y is equal to y naught plus, we combine these two terms UC1 into delta y naught plus UC2 into delta square y minus 1 plus U plus 1 C3 into delta cube y minus 1 plus U plus 1 C4 into delta raised to 4 y minus 2 plus next is U plus 2 C5 plus U plus 2 C6, here U plus 2 C5 into delta raised to 5 y minus 2 plus U plus 2 C6 into delta raised to 6 y minus 3 plus etc. This is known as the Gauss forward interpolation formula. Now, let me observe the difference table. As x, y, the first order difference delta y, delta square y, delta cube y, delta raised to 4 y, etc. The values of x are x minus 3, x minus 2, x minus 1, x naught, x1, x2 and x3. The corresponding y values are y minus 3, y minus 2, y minus 1, y naught, y1, y2 and y3. The differences are here we can write delta y minus 1, here delta y minus 2, delta y minus 3, and this is delta y naught, delta y1 and delta y2. These are the first differences. Now, the second order differences are here delta square y naught, delta square y minus 1, delta square y minus 2, and this is delta square y minus 3, here delta square y1. And the third order differences are here delta cube y naught, delta cube y minus 1, delta cube y minus 2 and delta cube y minus 3. And the fourth order differences are delta raised to 4 y minus 1, delta raised to 4 y minus 2 and delta raised to 4 y minus 3. The fifth order differences are delta raised to 5 y minus 2 and delta raised to 5 y minus 3. Then the sixth order differences, delta raised to 6 y are there is only one difference, that is delta raised to 6 y minus 3. This is the corresponding difference table. In this difference table, if we draw a central line, we can observe that the even order differences, that means delta square, this is the central line, the even order differences, that is delta square y minus 1, delta raised to 4 y minus 2 and delta raised to 6 y minus 3 are lying on this central line, and the odd order differences which are used in the Gauss forward interpolation formula, that is delta y naught, delta cube y minus 1, delta raised to 5 y minus 2 are lying a line below this central line, that is this is the line below the central line, in which line the odd order differences which are used in the Gauss forward interpolation formula are lying. And when we use this Gauss forward interpolation formula, it is better to choose x naught such that the value of u, that is u equal to x minus x naught divided by h, lies between 0 and 0.5. The value of u lying between 0 and 1, in order to achieve a better accuracy in the interpolating value. Now, let me conclude this session. In this session, we discussed the Gauss forward interpolation formula. Hope that you have understood the Gauss forward interpolation formula, and in the coming session, we shall discuss the Gauss backward interpolation formula. Thank you for watching this session. Have a nice day.